What's up everyone, Patrick here, welcome back, and moving on to some more expressions we have to simplify, some more practice dealing with the exponent laws. So we got 4 to the negative 2, all to the power 3, all to the power of negative 1 over 3. Now here, notice that this, even though there's 3 terms, it's in this format. So what we can actually do here is we can multiply these 3 exponents. And if it's hard to kind of maybe compare this to this because there's 3 exponents. So let's say that we ignored the negative 1 over 3 originally at the on the outside. Remember, you always want to work with the inside brackets first. So if we ignored that outside bracket, we'd have 4 to the negative 2 to the power of 3. So you could just multiply those, and that would give you 4 to the negative 6, but we'd still have that negative 1 over 3 outside. And then you could take the negative 6, multiply it by negative 1 over 3, that would give you 4 to the power of positive 2, right? Negative 6 times negative 1 over 3 gives you 2, so this would end up being 16, right? You want to be careful here. Again, there's so many different ways to go about this. You could take the 4 to the negative 2, you could change it to 1 over 16, and then you'd have that to the power of 3, and then that to the power of negative 1 over 3. But then things get a little bit more complex. You could then actually multiply these two. So that would be 3 times negative 1 over 3 would give you negative 1. And then here we'd have a fraction to the power of a negative exponent. So we would flip the fraction, 16 over 1 to the power of positive 1, which is like 16 to the 1, which is 16. Same answer. So again, different ways to go about it. Personally, I would have just multiplied all the exponents to get that 2 right there. Over here, got a fraction to the power of a negative exponent, so we would flip that fraction. The negative you could put with the 5. I'm going to keep it with the 4. This would be to the power of positive 3. And then that exponent, you would take the numerator to that exponent, and then the denominator to that exponent, like that. And then that denominator, that negative 4, you got to be careful. Make sure that that goes in brackets to the power of that exponent. Basically, this whole thing, that whole thing goes to the power of 3. So then you'd end up with what? 125. 5 to the power of 3 is 125. Negative 4 to the power of 3 is negative 64. And then to make it look nicer, you could put the negative at the top. Right, so negative 125 over 64 is the final answer. Number 3, we got negative 4 to the power of 4 to the power of negative 1. Now this one, it's actually kind of tricky. You got to be careful. And the reason why it's tricky is because of this term in the brackets. So this negative 4 to the power of 4. I actually want to just take some time to talk about this over here. This is different than this. Okay, so just be careful there, because this here, what it is, it's basically, it's not a negative 4, it's like a negative 1 in front of the 4. It's like negative 1 here times this 4 to the power of 4. Okay, so let me rewrite that again. The way we would write this is negative 1, 4 to the power of 4. Right? So it's the positive 4 that's going to the power of 4. And then the negative 1 is on the outside. And if you do BEDMAS, remember, exponents go first. So you'd have negative 1 times 256. Negative 1 times 256 would give us negative 256. Like that. Versus here, this would be negative 4, not positive 4, an actual negative 4 because it's in brackets to the power of 4. So this would be negative 4 times negative 4 times negative 4 times negative 4, which would give us, because it's an even exponent, this would be positive, and it'd be positive 256. All right, so this is negative 256. This here is positive 256. So just be careful in your homework or on tests differentiating between stuff like this. If there's no bracket here, then there's like a negative 1 in front. But if there is a bracket, then it's -4 to whatever that exponent is, right there. Okay, actually, if you want to generalize this, we could actually maybe even add that to the rules, but if you got -a to the power of x, this is like -1 times a to the power of x versus -a to the power of x would just be -a multiplied by itself to the power of, x times. Right, so just be careful with that. So this bracket, as we just showed, it's -256. So we'd have -256 to the power of -1. That's exactly like this over here. A term to the power of a negative exponent, we'd bring that term down, -256 to the power of +1. So in this step, notice the term doesn't change, right? That a is still in brackets, but the exponent changes from negative to positive when we bring it down. But this negative didn't change. That term stayed the same there, right? So we keep it at -256 there. And then -256 to the power of +1, anything to the power of +1, it's just itself. So we'd end up with 1 over -256, which would give us -1 over 256. Right, so this one looks simple when you initially look at it, but there's actually a lot going on there, a lot of tricks, so that's why I wanted to include it. So final answer for this is -1 over 256. And then we got 5 to the -2 plus 2 to the -3. Now this positive here, notice that there's no additions here or subtractions. So there's no rule we can apply here, even if they had the same base, like let's say this was 5 to the -2 plus 5 to the -3. You can't just add those exponents or multiply them or do something like that. You'd have to actually deal with both of these separately and then add them as fractions. That's what we're going to do here. Right now, if it was multiplying, then that would be 5 to the -5. You can use this law over here, right? But because they're adding, can't do anything. There's no law here to apply. We would apply this law to each of these individually. So we'd have 1 over 5 to the 2 plus 1 over 2 to the power of 3, which would be 1 over 25 plus 1 over 8. And then the common denominator between these would be 200, right? Both of them multiplied by each other. So multiply this by 8, multiply this by 8, this by 25, this by 25. So we'd end up with 8 over 200 plus 25 over 200, which would give us 33 over 200. And then that doesn't simplify any further. So that's the final answer to number 4.